Welcome to Section 4 on Tips and Tricks, where we'll be going over various things you should know in order to get the most out of TensorFlow. The section begins with a quick overview of TensorBoard, which is the topic of this video. Then we'll provide a deeper look into getting the most out of TensorFlow estimators, such as using training and evaluation hooks and different types of configuration objects. Next we'll go over best practices for training models, and we'll wrap up the section with a video on debugging strategies. Today's video is all about TensorBoard, a wonderful visualization tool that comes with TensorFlow. TensorBoard is the best way to monitor our model's performance, visualize its computation graph, compare performance between different models, and much more. We'll begin with a few slides introducing the look and feel of TensorBoard. I'll actually be showing screenshots of TensorBoard that are generated from the model code from Section 3, so that you can exactly reproduce everything you'll see today. After that, we'll take a peek under the hood of TensorFlow Summaries, which are the main data type for passing data to and from TensorBoard. Lastly, we'll summarize the basic workflow you'll do whenever you want to use TensorBoard for an estimator-based model. You may remember this plot from the final video in Section 3. It's the plot of our model's prediction accuracy over the course of about 5,000 steps. The orange curve is training and the blue curve is evaluation. Plots like these are generated for a tensor whenever you use tf.summary.scalar, and they're all placed in the Scalar tab in TensorBoard. Similarly, we can generate histogram plots for a tensor by using tf.summary.histogram. This will actually generate two different kinds of plots, one under the histogram pane and one under the distributions pane. The image shown here corresponds with the histogram pane, again for the model from the final video of Section 3. From left to right, we see a histogram for the word embedding tensor, the final R and N state after we concatenated all tuples together, and the output probabilities layer. Each step produces another slice in the direction coming out of the page, and each slice shows the distribution of values for that tensor for the given batch. This is what the distributions pane looks like, which is the same plots we just saw but the two-dimensional version, as if we are looking down on the 3D plots we just saw. Here the horizontal axis is the training step and the vertical axis represents the tensor values. Darker regions mean that more values are concentrated there, while lighter regions mean that relatively few units took on values there. One of the most fun parts of TensorBoard is the graph visualizer, where you can interactively explore your model's computation graph. Here's what our model from the end of Section 3 looked like. We see the input function at the bottom, whose outputs are fed into the large model function subgraph. Within the model function, we see the glove embed layer, followed by our deep bidirectional LSTM layer, then the dense layer for the logits, and prediction nodes for things like output probabilities and the argmax operation. We also see the train and eval subgraph, which contains things like our loss operations and the optimize loss operations. Finally, the metrics subgraph contains the operations resulting from tf.summary calls. Each subblock you see here, the ones I just listed off, correspond to a unique tf.variable scope, with names shown in the block. This is another reason to use tf.variable scope in your code, both to make it more readable and modular, but also to produce clean TensorBoard graphs like this one. Lastly, the TensorBoard Projector. It may be hard to see because of how small the words appear, but we are looking at the embedding space of our model, well, a three-dimensional projection of it. Each point you see is labeled by the word it represents. This tool is a really fun way for exploring how our pre-trained glove embeddings are represented in the embedding space. For example, in this screenshot, I've searched for the word person, and TensorBoard provides me a sorted list of the 100 closest words to person in the embedding space, and it also highlights them orange. Although the writing is a bit small, the top 4 results in the list are someone, anyone, and man, which indeed have similar meanings as the word person. I encourage you to run our code from Section 3 and launch TensorBoard so that you can further explore this yourself. We now know that TensorFlow Summaries are what we use to just make plots in TensorBoard, but what are they anyway? Well, just like the tf.train.example objects we use for saving TF records data, summaries are protobuf objects. Protobufs appear in many places in TensorFlow, and I've found that taking the time to familiarize oneself with protobufs makes the TensorFlow experience much easier. On this slide, I've copied some essential lines from the summary.proto file, which is linked in the additional resources slide. And the syntax for .proto files seen here is very straightforward to read, has a similar look and feel as Python. You can basically think of message keyword as having the same meaning as class in Python. Starting with the summary message near the bottom, we see that a TensorFlow summary is defined as a list of value objects, because the word repeated in .proto syntax just means a list. Okay, so a summary is a list of values, but what's a value? That's defined right above. A value object has a tag of type string, and exactly one of the attributes simple value, histo, audio, or tensor. Symbol value is what's used for tf.summary.scalar, histo is used for tf.summary.histogram, and so on and so forth. We've talked about TensorBoard and the Tensorflow Summaries that are used for interacting with TensorBoard, but how do we set up and launch TensorBoard in the first place? Lucky for us, TensorFlow estimators automatically take care of the setup needed to make TensorBoard work, and they will place all the files needed by TensorBoard in the familiar model dir that we pass to the estimator constructor. Once we start training, or anytime after we're done, we can launch TensorBoard by opening up a new terminal and entering the command shown on the slide. We must provide the path to our model dir by using the logdir command line argument as shown. Then to open TensorBoard and start playing around, we just need to open our preferred web browser and enter the URL to TensorBoard, which it will print out in the terminal after you enter the command. The default URL is localhost 6006. As always, make sure to read through the links here for an in-depth look at the topics covered today.